So today we are going to talk about derivatives of trig functions. So we've done a bunch of algebraic things, and now it's time to talk about some trig functions. So we have here, these are derivatives that we're going to have to know. The derivative of sine is cosine, and the derivative of cosine is negative sine. Now I'm going to just show you how we come up. Now they're both done very similarly, so I'm just going to do the derivative of sine and show you how we get cosine out of it. And then if you want to figure out the other one, then you can go for it. Okay, so we're going to start back with the limit definition of the derivative. So that's the limit as h approaches 0 of f of x plus h. So in this case, it would be the sine of x plus h minus f of x, which is sine, all over h. Okay, so we're going to need a trig identity in here. Now, this is not something that you have to memorize. You can look these up when you need them, because I know that I had to look it up, okay? So there's a trig identity that says that the sine of x plus h is equal to the sine of x times the cosine of h plus the cosine of x times the sine of h. Okay, so sine of x cosine of h plus cosine of x sine of h. So we're going to put that in its place here, okay? So we're going to write the sine, okay, so we're going to replace this with this here with this now, okay? So we're going to have the limit as h approaches 0 of the sine of x cosine of h, and then plus the opposite, cosine of x, sine of h, and then I still have the minus sine of x here over h. Okay, so now what I want to do is I'm going to just switch the order here of these two, because I really want this sign to go with this sign over here. So I'm just going to switch the order that I'm writing these in, okay? So this is the limit as h approaches 0 of the sine of x cosine of h minus the sine of x plus the cosine of x sine of h over h. Okay, so now what we're going to do is we're going to factor out sine in this first grouping. So when we do that, we're going to have the limit as h approaches 0 of the sine of x, then times the cosine of h minus 1 all over h, and then we have plus the cosine of x times the sine of h. Okay, so let's see. And this is also, actually, because I put this plus between them this is also over h, right? So basically I factored this part out here. Oops, sorry. So I factored this part out, and I did that, and then I broke it apart as two fractions. So basically I put this over this plus this over this. Okay, so now I have these two fractions, and in this part here I factored out the sign to get this. Okay, now if you remember over here we have this, if you notice in here, this sine of h over h. We're taking the limit as h approaches 0 of this, and so we're allowed to do things separately. So I'm going to go ahead and take the limit of this part right here, right? And this is going to give me just 1, because the limit as h approaches 0 of sine of h over h, this limit right here of this is 1, okay? Now cosine of x is completely unmoved by this h approaching 0 because it doesn't have an h in it. So this piece right here is plus the cosine of x. Now this piece over here is really, this is sine of x, right? And then this is the other important trig identity here. This cosine of h minus 1 over h, right? This was the other one as h approaches 0. Remember we learned the two. The one was sine of h over h, which was 1. So I have 1 times cosine. This one here, the cosine of h minus 1 over h, was 0. So I have sine of x times 0 plus the cosine of h, and in the end I get the cosine of x, because sine times 0 is 0. And so then I can officially say that, if, let me say that f of x is sine up here, right? That's what I used. So that means that down here, this is f prime of x. And that is how I come up with the derivative of cosine is equal to sine. Now it's exactly the same process, it's just that there's a different identity that you would use for using cosine. But for right now, you don't have to prove this. You just need to remember this and this. They're the basis for everything else. As long as you can remember these two, then you can build all the rest of the trig around them if you accidentally forget them. Okay, now, all right, so let's just use this for a second here before we move on to the rest of our trig functions. So we have a particle that's moving along a coordinate axis. Its position at time t is given by s of t equals the square root of 3t plus 2 cosine of t for between 0 and 2 pi. And at what time is the particle at rest? Okay, so the first thing we need to know, well, this is a position function, right? And so the particle will be at rest when its velocity is 0, right? That makes sense, that velocity describes how fast it's moving, and if the velocity is equal to 0, then that is when my particle is at rest. So that means that we're going to find s prime of t because that is v of t, and then we're going to set that equal to 0. Okay, so we have our first derivative using cosine here. So s prime of t then is, this is my s of t, right? So this is plain, right? This is not the trig function. So the square root of 3 times t, the derivative is just the square root of 3. And then I have plus 2 times the derivative of cosine, again, is negative sine of x. Oops, I'll use t because we're using t, okay? And so now I need to find when this is 0. So I really have 0 is equal to the square root of 3, and then really I have minus 2 sine of t. I don't like it like this because it kind of looks like 2 minus sine, and it's really 2 times negative sine. Okay, so now I need to solve this. So I'm going to solve it for sine. And so I'm going to, actually I'll add the 2 sine of t to the other side to make it positive. I have the 2 sine of t is equal to the square root of 3. And then we divide both sides by 2, and essentially I get the sine of t is equal to square root of 3 over 2. Now, if this were some angle that I didn't know, right, then I should use my arc sine. This one I do know, so I can answer it exactly. So again, right, sine is my y-coordinate, and so that means that this must be at one of these places here. That's 1/2 square root of 3 over 2, right, which is a multiple of pi over 3. So this is at pi over 3. Now my pi over 3 really should probably be more like up here, but I know that this pi over 3 will work for me. Now this says for all of t between 0 and 2 pi. So now I do know that pi over 3 will work, and I know that there's actually 4 angles of pi over 3 that have sort of some combination of these coordinates. But I want my sine to be positive, and so that means that the only other place, remember sine is y will be positive over here, right? So this would be 2 pi over 3 over here. So my two solutions are t is equal to pi over 3 and 2 pi over 3, because at 4 pi over 3, my sine will be negative, and at 5 pi over 3, which is over here, it will also be negative because y is going down, okay? So those are my two solutions. Okay, so let's move forward now with, let's look at the derivative of tangent, okay? So we're going to figure this out ourselves. So really, instead of tangent, because I know that tangent could also be called sine of x over cosine of x, that's what we're going to rewrite it as, and we're going to use the quotient rule now, okay? So our quotient rule says that we always have the bottom, right, times the derivative of the top. The derivative of sine is cosine. I'll just write them up here just in case. So the derivative of sine is cosine, right? And the derivative of cosine is negative sine. Okay, kind of a pattern. You haven't seen it yet, but anything that's the derivative of anything that starts with a C, any of the trig values, they're always negative. Okay, so keep that in mind. All right, so I have the bottom times the derivative of the top, right? So derivative's top is cosine, minus then the top times the derivative of the bottom. The derivative of the bottom is cosine, so this will be times negative sine of x, all over the denominator squared, cosine squared of x. Okay, so on the top, okay, so I'm just going to call this f prime of x equals, I don't like it just floating around. So on the top, this is minus sine times minus sine. So really I could call this, now this is cosine times cosine, so this is cosine squared x, and then this will be plus sine squared x over the cosine squared of x. Here's my f prime of x. Now hopefully you remember the vital trig identity that says that cosine squared plus sine squared is actually equal to 1 over cosine squared of x. And really, 1 over cosine is secant, and so we really have secant squared of x. Really, this is my derivative of tangent. So now we can say that the derivative of tangent of x is secant squared x. Do you have to do that every time? Absolutely not. You can just remember this. Although I might ask you, in a possible test situation to do one of these, okay? Now cotangent is done exactly the same way. It's just that this cosine is on top and sine is on the bottom. You can check that out for yourself, but the derivative of cotangent of x, I'm just going to give you, which is negative cosecant squared of x. I like to do the ones that are positive. I'll leave the other ones for you. I mean, you can try it out if you'd like, okay? So this is another one that we should remember, that the derivative of cotangent is negative cosecant of x. I know cosecant squared of x, so it's kind of like tangent is secant squared, cotangent is negative cosecant squared. So they're kind of the same, but a little bit different. And again, anything that starts with a C, the derivative is negative. Okay. So we're going to do the same thing this time with secant. Okay, so the derivative, or really secant, is really 1 over the cosine of x. Okay, so to do the derivative, I'm going to use, actually, no, I'm not. I'm going to use the quotient rule here, okay? And so that means my bottom, I'm going to have the bottom, which is the cosine of x. I'm going to write this as prime here. Cosine, the bottom is cosine times the derivative of the top, which is 0 in this case, and then minus 1 times the derivative of cosine, which is negative sine, all over the bottom squared, which is cosine of x squared. Okay, so now we have cosine of x times 0, so that's gone. And then I have a negative times a negative, so I'm just left with sine of x over cosine squared of x, which we then break apart. So this is the way we sine times 1 over cosine of x, which then this is tangent of x, and then this is, oh, I'm very sorry here, okay. So I have sine of x from the top, right? I have negative times a negative is positive, gives me sine of x over cosine squared of x, and then I'm just rewriting this as sine over cosine times 1 over cosine. So if I multiply by this back together, I get this, but now I know that sine of x over cosine is tangent, and then this one is secant, okay? We usually write it as secant tangent or tangent secant, it doesn't matter, but the derivative of secant is secant of x tangent of x. Oops, which I wrote up here. Okay, so that's another one. I guess I should have used another piece of paper for that, okay? So that's the derivative of secant. Now I'm just going to give you the derivative of cosecant. So the derivative of cosecant of x is, again, anything that starts with a C is negative. And this is kind of, so this one is secant, this one is negative cosecant of x, and this one is tangent, this one is cotangent of x. So they're similar, but slightly different, okay? So there's some similarities there to help you remember them, okay? So these are our basically 6 big ones. We want to remember right? These two up here, the derivative of sine and cosine. And then you probably don't want to redo them every time, so you probably want to remember that tangent is secant squared, derivative of secant is secant tangent, derivative of cotangent is negative cosecant squared, and then cosecant is negative cosecant of x times cotangent of x. So that's all 6 of our trig identities that we now know the derivatives of. All right, so we're going to play with a few derivatives here. So we're going to find the 4th derivative of sine. Okay, so we're going to use some of our higher order derivatives here. So y is sine, so that means that the first derivative is cosine. And then y prime, double prime, is the derivative of cosine, then we know is negative sine of x. Y triple prime, right, is equal to, the derivative of sine is plain cosine, but it's also got a negative inside, so this will be negative cosine of x. And then the 4th derivative we just write as y4 is, so cosine is negative sine, so negative cosine will be positive sine of x. And we're right back where we started with. And sine and cosine both do this with this basically cyclic thing. Because then if I start over again with sine, right, the 5th derivative would be cosine, the 6th derivative would be negative cosine or negative sine, the 7th derivative would be negative cosine again, and the 8th derivative would be positive sine. So every basically 4th derivative, I'm going to end up right back where I started from. So let's use that to kind of think about what would be the 25th derivative of sine. So based upon this, right, so it's kind of like the 4th derivative would be sine, the 8th derivative would be sine, the 12th derivative would be sine, right, every 4. And so what's the biggest number, or multiple of 4, that will fit into 25? Well, that would be 6 times 4 is 24, right? So we know that the 24th derivative will be sine, right? And so that means we need one more derivative, so the 25th derivative would just be cosine of x. Okay, so it's just kind of like pattern recognition here. I thought that was kind of interesting. All right, so let's just do, right, some derivatives. So now that we know our trig derivatives, all the same rules apply, right? All the constant multiplier rules work. The product rule is the same. We've already used the quotient rule, but we're going to use it again. Okay, so we're just going to do the derivative here. And this is just, I just want to do an example or so of ones that have cosine, and we need a rule. Okay, so we have x over cosine of x, which means I need to use the product rule, or I'm sorry, not the product rule, the quotient rule. So the quotient rule goes the bottom, which is cosine of x, times the derivative of the top, which is 1, minus then x, and then times the derivative of cosine, which is negative sine of x, all over cosine squared of x. And so my f prime of x derivative, just to clean it up a little bit, is the cosine of x, and then this will be plus x sine of x over cosine squared of x. And again, just like all the other derivatives that we did, just leave them, it's fine. Unless you're trying to show me that the derivative of secant is secant tangent, then you don't need to simplify for right. I mean, we're just doing derivatives. So let's do one product rule then. So what if we have f of x equals, we'll say, how about cosine of x tan of x? Okay, so this time, again, we need the product. This time we need the product rule. We haven't really used that this time. The product rule says the derivative of one times the other, and then plus the opposite then, the derivative of the other times the first. All right, so I'll just start with the derivative of cosine, which is negative sine, and then tangent is here. That just comes along for the ride, right? It's the derivative of the first, then times nothing happens to the second part. And now we're going to have cosine times the derivative of tangent, which we just learned is secant squared of x. Now, there's all kinds of simplification that I can do in some of these, right? Now, really, there's not a whole lot on this, because if I change tangent into sine over cosine, then I'm just going to get negative sine squared over cosine. But this one I could simplify a little bit because secant squared is really 1 over cosine. You don't have to do this. I'm just pointing this out, that this could be cosine of x times 1 over cosine squared of x, right? And so this cosine would cancel with one of these, and then this whole side would then just be 1 over cosine, which would just be secant of x. So I could simplify it a little bit by doing that. It's not necessary. I'm just pointing out that it could be. This is an equivalent answer. Okay. All right.